Hello, Workplace 11, and a couple apologies to start today. I have my common apology of the dryer, which is zipping away there. And then I also want to apologize because I'm going to start with scale factor today, and I've already made a video on scale factor for a different course. So I'm going to cheat here. I'm going to stop in a second, and I'm going to just put in the video that I made with the other course. Now I'm hoping you almost won't even notice. If I hadn't said this, you might not even notice. But there might be a time or two in the video that I say something like, remember last class when we were talking about similar figures or something, and of course that's not actually accurate. We weren't talking about that last class. So I'm sorry for any minor confusion that this causes, but it's going to save me a lot of time. So in a second here, I'm going to switch over to the old video. See if you can spot the switch point. It won't be right away, but it'll be soon. So what we're going to talk about are similar figures. And what similar figures are figures that have the same shape but possibly different sizes. So for example, if I was to draw a triangle like this, and then to draw another triangle here, these are similar figures because they definitely have the same shape, don't they? They look exactly the same. The only thing that's different is that one's bigger than the other. Now, if I was to draw a triangle like this, that's not a similar figure than with the other two because it looks different. This is a right triangle, this is a right triangle, this is not. The other way you can think of this is these two triangles, they're proportional, right? However much bigger this side is than that side, say it's twice as big, or 3 times as big, let's say. Then this side is also 3 times as big, and this side is also 3 times as big. So that's what makes similar figures similar figures. Okay, so similar figures are found everywhere in life. Think about things like maps, blueprints of buildings that architects make, models of atoms. When you draw a map of Canada, hopefully your map's going to look just like the real Canada. It's going to have the same shape as the country of Canada, right? It shouldn't look completely different. That wouldn't make sense. But it's certainly not going to be the same size as Canada. You don't have a piece of paper that big. When you make a model of an atom, it should be very accurately drawn to have the same shape as a real atom. But it's certainly not going to be the same size as an atom. You wouldn't be able to see it then. Okay, so this takes us to this idea of two types of similar figures, reductions and enlargements. And I bet you can figure out what those mean. Basically, when the new object, or the new image I should say, is smaller than the original object, this is called a reduction. So for example, a model of a train engine. You get your materials out and you build a model of a train engine. And now it's sitting on the desk in front of you. This beautiful train engine staring you in the face. Well, I would imagine that your train engine on your desk is a lot smaller than a real train engine. Otherwise it's going to crush the desk and you. So it's a reduction. It's taken a real object, which is the train, and it's made a new, smaller version of it. But it should be the same shape, right? The wheels should be proportional to the real train. The door that the engineer walks in should look proportionally the same as the door of the real train, etc., etc. With an enlargement, as you can guess, the new image is larger than the original. Think about the COVID virus that you keep seeing pictures of in the news and everything. The real COVID virus is very, very, very small. And when you see these drawings that artists have drawn of it, it should be the same shape as the real virus, but obviously it's a lot larger. So this is an enlargement. Okay, so scale factor, which is the key to the lesson today, is a number that gives you a sense of how much bigger, how much smaller, how much is it reduced, how much is it enlarged. And so I really recommend, I insist that you write down this formula. You're going to need this over and over and over today. Scale factor equals image length divided by object length. So let's think about this. If you had an enlargement, think of the virus here. You have an object, which is very, very small, the virus, and you have an image, the drawing that someone's done of it, which is bigger. So if you take a big number and divide it by a small number, what kind of number do you get? You get a fairly big number. You get a positive number, and you get a number that is bigger than 1. If the scale factor is larger than 1, it's definitely an enlargement. Now let's think of the model train. You have an object which is very big, a train, a real train is very big, and then you have your model of a train which is very small. If you take a small number and divide it by a big number, what kind of numbers do you get? I heard some of you say negative. That's not correct. If you take a number like 10 and divide it by 500, what do you get? You get a decimal or you get a fraction. You get a number between 0 and 1. And basically, if your scale factor is between 0 and 1, you've got a reduction. Now, what about a scale factor less than 0? Negative. That doesn't make sense. Okay, there's no such thing as a scale factor less than 0. How about a scale factor that is 0? That doesn't make sense either. That would mean like the thing disappearing or something. There's one other possibility. What if the scale factor is 1? What would that mean? Well, that would mean that the image and the object are exactly the same. Let's say you were drawing a worm. You put the worm on the table in front of you, and then you drew a picture of the worm that was exactly the same size as the worm itself. Then your image length and your object length would be exactly the same. When you divide two numbers that are exactly the same, you get 1. So if the image and the object are the same size, the scale factor is 1. Okay, lots of notes there. Sorry about that. But this scale factor formula here is the key to the whole thing. We're going to use this over and over on the next page. Woo! Okay, let's do it. Wait, I just thought of something. Your book uses slightly different terminology. So object length, this is what they refer to as original, right? That's what you started with. And the image length, that is the new. That's the new length or whatever. So you could also think of the scale factor as being new divided by original. Maybe that's even better. So scale factor equals new divided by original. That works as well. All right, here's the questions. Find the scale factor of the following enlargement. So this is our original or our object, and this is our new or our image. So if we want to find the scale factor, basically what we want to do, well, already actually you should be able to tell me something. Look at the new, it's bigger. So what do you know about the scale factor? The scale factor is definitely going to be more than 1, right? If it's an enlargement, this is an enlargement, then it's going to be more than 1. So you can measure wherever you want on this star as long as you measure the same distance over here. Don't measure from here to here and then measure from here to here and compare those. That would make no sense. If you're going to measure from here to here, you better measure from here to here and that one as well. All right, so I need to get my ruler here, and I'm going to measure from arm to arm here. So it looks like I have 24. So let me set this up here. Scale factor is what we're trying to find out, and it equals new divided by original. Terrible writing. And I found that from here to here is about 24, and that is original, 24 millimeters. So I'm going to put 24 on the bottom here. All right, now I need to measure that same distance on the new image. And it looks like it's close enough to 60 that I think I can call it 60. 6 centimeters or 60. So I put 60 in here, and then I can divide. I could actually divide them both by 12, and I get 5 over 2. That's an acceptable answer. That could be your scale factor. You could also divide this and get a decimal, 2.5. That's probably my preference. 2.5 is a good answer. You could also, I'm not such a big fan of this, but your book does this, so I better tell you. You could also write it like this, 5 to 2. That works as well. So what does that mean? Let's look at the 2.5. What does that mean when you find the scale factor is 2.5? Well, it means it's an enlargement because it's bigger than 1. How many times bigger is this one than that one? 2.5 times. It's 2.5 times as big. Okay? Now we're going to do the opposite. I give you the scale factor, and we have to draw the reduction. This time we're going to reduce by a scale factor of 1/2. All right, I'm going to start by writing down my formula because we use it for everything. Scale factor equals new over original. Oh my gosh, my writing. Scale factor, we know. The scale factor is right there. So where it says scale factor, I'm going to put 1/2 equals. All right, this is our original, right? Original. So let's get some measurements for this. If I measure from here to here, it looks to be about 67, which is a bit of an unfortunate number, but I'll put that in there. And if I measure from here to the top, it looks like it is 27. So I'll write 27 here. All right, let's do one dimension at a time. Let's do the width first. So the scale factor is 1/2. Our original width, I'm going to put width here just so we know what we're talking about. Our original width was 67, and I have to figure out the new. How am I going to figure that out? I don't know it. That's an unknown amount. I'll call it x. Guess what I can do? I can cross multiply. 1 times 67 is 67. Divided by 2, I get 33 and a half. How about for the height? So height, again, scale factor is 1/2. That's what it told us in the question. Scale factor is 1/2. The original height was 27, and I don't know the new height. That's what I'm trying to figure out. I'll call it y this time. You could call it x again if you want. Y equals 1 times 27 is 27, divided by 2 is 13 and a half. So let's create this thing. I'll move my ruler down here, and I need a height of 13 and a half. So that would be from right here to 11, 12, 13 and a half, right around there. Okay, then I'll flop this over, and I need to go, how much? 33 and a half. So 31 to 32, 33 and a half would be right around there. Come on, yes. And if I could move this up and do the same thing here. 33 and a half is right around there. Get rid of the ruler, get my line making machine here, and connect these here, 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 and here, and we have done it. This is a reduction of 1/2 from the original. So this is our new or our image. Now I know what you're saying. You're saying, what? That's a reduction of 1/2? That doesn't make sense. Look it, I can actually fit 4 of them perfectly in here, and you're telling me it's a reduction of 1/2? It is a reduction of 1/2 because the height is half as much, right? I can only get 2 heights in there, and the width is half as much. I can only get 2 widths in there. If you're looking at area, which we won't do until Foundations 12, then you have to square those amounts, and it's 4 times left. Sorry, Foundations 11. So don't worry about that. We won't do area and volume this year. But that's why it doesn't actually look half as big. Area-wise, it's only 1/4 as big. But length and width-wise, it's half as big. And that's what we wanted, a scale factor of 1/2. All right, in your book, one of your homework questions is exactly this. I think the things are written in a different order, but I like this order better, so I went with it. All the questions involve scale factor. So you're going to have your scale factor equals new over original, or image over object. Here's your object, the original, and here's your image, the new. And for this first question, we have to get the scale factor. Well, scale factor equals new, that's 60, divided by original, that's 20, and if you divide those, you get 3. Scale factor is just a number, no units. I forgot to say that in the notes, but there's no units for scale factor. You do not put 3 centimeters for this. 3 means 3 times as big. Okay, it wouldn't make sense to say, oh, it's 3 centimeters as big. Does not make sense. No units on scale factor. So is this enlargement or reduction? Well, you should be able to answer that just by looking at this number 3. If it's bigger than 1, it is an enlargement. You should also be able to answer it just by looking at these two numbers. If it was 20 and it went to 60, that's definitely bigger. 60 is bigger than 20. That's an enlargement. All right, the second one. Same formula. I'll move it over here. We know the scale factor this time. It's 0.75. So I'm going to write that down, 0.75. Do we know the new? No, we don't. Well, why don't I call that n for new? Do I know the original? Yeah, I do. It's 80. There we go. Okay, I got to solve this. Looks like algebra. I have n divided by 80. So what are you going to do? You're going to multiply both sides by 80. So I get n equals 0.75 times 80. And if you multiply that, you get 60. So we know that this one here is 60 centimeters. Okay, it was 80 and then it went to 60. Got smaller, that's a reduction. Or if you like, 0.75 is less than 1, so that's a reduction. All right, the third one, same formula. Do we know the scale factor? Yeah, we do. It's right here, 3 to 2. But don't write it like this. 3 to 2 equals, that's very confusing. It's going to be next to impossible to answer that. Can you think of a better way of writing 3 to 2? I can. write it like 3 over 2. Or the other way you could do is you could divide 3 and 2 and get 1.5. That'll work as well. Anyway, don't raise a ratio this way. Write it. This is still a ratio. It's a fraction, though. A fraction's a type of ratio. All right, do we know the new? Yeah, we do. The new is 25. Do we know the original? No, we don't. Let's call it, I don't want to call it O because it looks like 0. I'll call it M. Okay, we could solve this by cross multiplying. M equals 2 times 25 is 50 divided by 3. You could put that as your answer, 50 over 3. Or if you divide that, you get 16.6 repeating centimeters. Enlargement or reduction? Well, we went from 16.6 up to 25. Oh, it got bigger. That's an enlargement. Or look at this, 3 to 2. Remember I said you could divide and get 1.5? That's bigger than 1, so it's an enlargement. Okay, so the key today is this formula. Use that and you can't go wrong. Well, you can, but you're less likely to go wrong. All right, I'm back live. I hope that went okay. Thanks for putting up with my recycled video. I hope everything makes sense. If not, let me know. I'm always here for you guys. Take care. Bye.